Okay, next theorem we're looking at is the triangle inequality theorem. So this says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So I mean, if you think about why that is, let's say that I have that this side is 10, this side is 15, and it doesn't look like it, but let's say that this is 1. That could not work because imagine these two sides are flat. So imagine I could draw a straight line. So there's side CB. And so we already said that that's 15, right? Now, if I have side CA to be 10, if I have this little portion there that's 1, that's AB, notice that's 11. There's no way that even if these were stretched out, that they could reach the endpoint here. So the sum of any two sides of a triangle is greater than the length of the third side. This doesn't hold because 10 plus 1 is 11. That's not greater than 15. It can't make a triangle. Now, if this were, say, 6, it absolutely would be true because 10 plus 6 would equal 16, which is greater than 15. So, determine whether the measures of the sides can be a triangle. So here, 3, 4, 6. Well, 3 plus 4 is greater than 6. That checks out. 3 plus 6 is 9, which is greater than 4. And 4 plus 6 is greater than 3 because that's 10. Perfect. 3 for 3. Yes. 6, 9, and 15. Well, if we do the first one, 6 plus 9 is equal to 15. It's not greater than 15. So already I'm done. No. As soon as I get one case where this is not true, then I know the rest of them are false. That cannot be a triangle. Let's do the same situations here. So 2, 3, and 4. So 2 plus 3 is 5, which is greater than 4. That's true. 2 plus 4 is 6, which is greater than 3. That's true. And 3 plus 4 is 7, which is greater than 2. So yes, number 1 can be a triangle. Number 2, we have 5 plus 7 is equal to 12. So 12 is greater than 9. Yes. 5 plus 9 is 14, which is greater than 7. Yes. And then we have 7 plus 9, which is greater than 5. So that means that number 2 is also a triangle. So far, so good. 4 plus 8 is greater than 11. That's okay. 4 plus 11 is greater than 8. And then 8 plus 11 is greater than 4. So look at that, all triangles that work out. Oh, but yet again, 13 plus 13 is equal to 26. So it's not greater than 26. So no, this cannot be a triangle. So 3 for 4 there, not bad. Here we have a nice little application problem. So determine whether the given coordinates are the vertices of a triangle. So basically, could these make up a triangle? Well, what we've been doing is we've been looking at distance. So we have to figure out the distance of these triangles, distance of these sides. So AB is the square root of 3 minus 4 squared plus 5 minus 7 squared. So this is 1 plus, that's negative 2 squared, which is 4. So AB is the square root of 5. BC is going to be the square root of 7 minus 4 squared plus 6 minus 7 squared. So that's 3 squared, which is 9, plus 1 squared. So BC is the square root of 10. And so finally we need AC. So AC is the square root of 7 minus 3 squared plus 6 minus 5 squared. So we get 4 squared, so that's 16, plus 1. So AC is equal to the square root of 17. So with this, with square roots, you may need to use a calculator, get some decimals. So the square root of 5 plus the square root of 10, that would be about 5.4. And if we do the square root of 17, so square root of 5 plus the square root of 10 is greater than the square root of 17. Square root of 5 plus the square root of 17, that should be greater than the square root of 10. And it is. And then, of course, the square root of 17 plus the square root of 10 is absolutely going to be greater than the square root of 5. So yes, this all works out for that problem there. So I'm going to do the same approach for number 18. So ST is going to be equal to 6 minus 8 squared plus 5 minus 3 squared. So this right here is 2 squared, so that's 4 plus 4. So we get ST is equal to the square root of 8. We can work right here, so TU is equal to the square root of 8 minus 12 squared plus 3 minus negative 1 squared. So this is going to be negative 4 squared, which is 16, plus 16. So TU is the square root of 32. I'm not reducing these, but that's fine. I mean, I'm just going to get decimal approximations anyway. And then so SU is 12 minus 6 squared plus negative 1 minus 5 squared. So this is 6 squared, which is 36, plus negative 6, so square root of 72. Now that's pretty big. So actually if I do the square root of 8 plus the square root of 32 in my calculator, square root of 8 plus the square root of 32, that's about 8.4. And the square root of 72, that's actually the same value. So because they're equal, no, this cannot be a triangle. So there we go. We didn't have to do much work there. So distance formula coming back to haunt us. But really the concept is the same. You're just finding out all the different combinations and finding out these inequalities and to make sure that everything works.